This is exercise 1, question 3, similar to the slide actually. Given this one, so this one is exact solutions. This one exact solution. Now they want you to replace the exponent x squared by this. They use bottom because as I explained in the lectures, okay, exponent x can be approximated using Taylor series as 1 plus x squared over 2 factorial plus x power 3 over 3 factorial up to n, x to the power n will be n divided by n factorial. So if you want exponent x squared, so this is just replace x by x squared. So x squared, here we have an x squared, you squared again, divide by 2 factorial plus x squared and then cube divided by 3 factorial up to x squared power n divided by n factorial. Okay, and then if we just take up to the 1, 2, 3, 4, so 1, 2, 3, 4 term. So if we take up to the 4 term, okay, this one is a truncation error. So mean the truncation errors here is up to the order, okay, what we call order, okay, 8, because power 8. Okay, so now if you use 4 term, what you need to do, you just replace the exponent x squared by this 4 term. And now you just replace the exponent x squared by 1 plus x squared plus x power 4 divided by 2 factorial plus x power 6 divided by 3 factorial, okay, and then dx from 0 to 1 over 4. Okay, and then now you just integrate term by term. So integrate 1 will be x, integrate x squared, you have x cubed divided by 3. Okay, x power 4, you have x power 5 divided by 5. Okay, initially you divide by 2 factorial, which is 2. And then integrate x power 6, you have x power 7. Okay, divide by 7. 3 factorial is actually 3 times 2. Substitute the limit from 0 to 1 over 4. Okay, so now you substitute, upper limit is 1 over 4, so 1 over 4. Okay, so you substitute, this is 1 over 4 to power 3. Okay, divide by 3. So 1 over 4, okay, power 5. Okay, divide 5 times 2 here, 10. So plus 1 over 4, okay, power 7. Okay, divide by, this is 7 times 6. Okay, when you substitute limit, lower limit 0, okay, to the term here, everything is 0. Okay, so please evaluate this one using your calculator. This calculator cannot use this pen. Okay, so is it clear? So now up to this step, please just use a scientific calculator to evaluate it. Okay, or you want to evaluate manually, also can. okay, plus 1 4 power 3, right? Is equal to multiply by 3 plus 1 over 4 power 5 multiply at the denominator you divide by 10, okay, and then plus 1 over 7 power 7, okay, multiply 32, 1, 2, 3, 4 term. Okay, so please check whether you key in correctly. Okay, scroll left, right to check whether you key in correctly. Okay, that's why at least you have the ES plus you can see in the natural display whether you key in correctly, and do in one step so you can get a better accuracy there. If you round it, let's say this one port you round it, this one you round, okay, each step you round, you will introduce more rounding error rather than calculate in one step. Okay, so you get the answer 0. They want to round to how many decimal places?
3.
Then you just round it to 3 decimal place, will be 0.255. You round to 3 decimal place, 255, 0.255. So this is question 3. So any more questions? The rest is similar technique with the slide.
Thank you, Doctor.
Welcome. Is there any more? Okay, the rest just calculate. Question 4, calculate absolute and relative error. Okay, is there any more questions? Okay, for other questions? Okay, if not, you may take some time to do first.
Doctor, the number 4, I'm confused about that question.
Yes, which question? Yeah, Muhammad Faiz, which question? Muhammad Faiz, so you're talking, which question? Muhammad Faiz, come on, just now you're talking something, right? Okay, Muhammad Faiz, just now what are you talking? I didn't hear.
The number 4, I'm making kira macam saya buat setengah jalan saja, tak buat habis lagi. Sebab tu macam tersangkut.
This one is exact. This is approximate. Absolute error. Okay, absolute error just take magnitude. See, In the calculator, you have the absolutes. Let me find the button. ABS. You find in your calculator, you got ABS there, stand for absolute mean. If you for example, this is brown color, so shift this one. For example, you put -5. You change it to magnitude only. So you use this button. You put exact minus approximate or approximate minus exact doesn't matter because you always take the magnitude. So if negative, you make it become positive. And then you just key in. Any problem? 7, 1, 8, 2, 8, 1, 8, minus 2.7182. Press it. So this is the absolute error.
Oh, okay, Doctor.
So you obtain the this one is absolute error. So if you want relative error is the absolute error. This one already have So mean you take this one. Now your absolute error is stored in the answer in your calculator. So you just press divide. You want to divide relative error divide by the exact solution. So if your exact solution negative, make it become positive because we take the magnitude only. So divide by 2.71828818. If you want, so this is a relative error. If you want in percentage, you multiply by 100. So this is so if you multiply 100, make sure behind you put out percent. So mean this one relative error in the percentage. So clear? So same with the B and C, similar. Absolute error, take exact minus approximate or approximate minus exact, doesn't matter as long as if you get answer negative, make it become positive. That's it. So B and C should have no problem, right? Same thing.
It's not the same thing.
So 3, 4, done. 2. Chopping and rounding. Are you clear? Chopping and rounding, who are not clear. Find the question 2, find the 6-digit representation of the above number by, I think rounding you have no problem. Rounding. Let's say we pick 6-digit. What is question C. 6-digit. The first digit here. 1, 2, 3, 4, 5, 6 up to here. One, two, three, 5, 6. Up to this number. If chopping off, you truncate at all. 2C 255307. Like the first digit there not complete. Let me see. If this one 1, 2, 3, 4, 5, 6. If This one, okay, the 0 in front not calculate. That's why I take out one more digit. If chopping, just throw away the digit behind. Round off, okay, you have to look at the digit behind. If greater than 1, then you increase 1. Increase 1 to, okay, the last digit, okay. So this one, let's look at B first. 6 digit, 1, 2, 3, 4, 5, 6. So if chopping, you just throw away 1, 8, 2, 8. 2.787828. So chopping, you throw it, and then if round off, because 1 here not greater than 5, so you no need to increase 1 to the last digit 8 here. So chopping and the rounding, same answer. Okay. Only this one, C, if the mean is 0 point, the 0 here, this digit is not count. The count for 1, 2, 3, 4, 5, 7. So 1, 2, 3, 4, 5, 6 up to here. So if chopping, this one throw. So 0.255307. This way you see 1, 2, 3, 4, 5, 6. Okay, and if rounding, okay, because 5 here, okay, for rounding, if the digit behind that you are going to round or chop greater or equal to 5, you increase 1. Because this is 5, so you increase 1 to this 8 here. So 8, you increase it by 1. So the answer is 0.255308. So this is rounding. It only for the floating point, if before the decimal place, if 0, they not count. The count start from the behind. But if this, so this, in the example, if this is 1, it is count. So this is a question 2 and 1 also. Okay, 1 also, okay, it's okay. Exact, you just directly press your calculator. Okay, so any more question for exercise 1?
No, doctor.
If not, you take 5 minutes. I'm going to change the computer, and you can go to the author to download 2 more, I think maybe the bisection lecture there from the author. Okay, take 5 minutes. I'm going to switch the computer.